I want to talk a little bit about something called an infinite series. This is a strange thing where you add infinitely many numbers. So like this, 1 plus 1/2 plus 1/4 plus 1/8, then you just keep following that pattern and you add it up forever. It turns out that sometimes this will give you something finite, and sometimes it just gives you something infinite. And it can be challenging to determine whether you're getting something finite or something infinite. And I want to just walk through some of the steps of basic intuitive ideas for simple examples that you can grab onto and hold on to as you move out toward more complicated examples. So first I actually want to think about this. This board is maybe about 6 feet. So let's say it's about 6 feet long. If I start at the beginning at 0 and then go half the distance to the end of the board, so I go to 3, and then from there I take the distance that's left, 3, and go half of that, so 1.5, and then from the 1.5 feet that are left I go half of that, so 0.75, and then I just keep doing this. If I keep going half of the distance that's left over, I will never reach the end of the board. And physically, of course, this is impossible for me to do forever, but if we can follow this idea, so I can write down what I'm talking about. If I do 3, so the first 3 feet, plus half of that, plus half the distance that's left over, and keep going, you can see I will never get to 6. So this has to give me something finite. But also, it cannot possibly give me anything less than 6. Because if you hand me any number less than 6, that's as close to 6 as you want, like 5.999999999, I can take enough steps to where I can get past your number. And yet I will never reach 6. So, if we're going to agree to let this be equal to something finite, then it cannot be anything bigger than 6, and it cannot be anything smaller than 6. So, we'll just say it's equal to 6. And if we do it that way, we can build something mathematically, logically comprehensive, something that makes sense, that we can build a whole system off of. So we'll say that this is equal to 6. All right. This is similar. So if you pause and take a guess at what this is equal to, you may be able to get the answer. We can think about this one also in terms of a distance. So if I start by going a distance of 1, and then I go a distance of 1/2 from there, and then I go a distance of 1/4 from there. Notice what I'm doing is I went a distance of 1, and then the next step I went half of that, and then the next step I went half of that, and then the next one is half of 1/4, and so on. This follows a similar pattern to what we did here with walking to the edge of the board. So you can probably guess now what this is equal to if you didn't get it before. We're starting with half of the distance to 2, and then we're taking another half step of what's left over, and a half step, and so on. So this will never hit 2, but it will approach 2. So we'll say that this is equal to 2. And both of these infinite series, these infinite sums, follow this pattern of the next thing that you're adding is there's a certain ratio that you can multiply each term by to get to the next one. So each term is a certain ratio of the term before that. That has a name. I'll talk about it in a couple of minutes. Before that, I want to look at 2 other simple series to keep in mind. For the first one, I'm going to take all of these and I'm just going to add 1 to the denominator. So I'm thinking of this one as 1 over 2 to the 0, or 1 over 1. All right. For this guy, I actually don't know what this is going to be equal to. And I don't have a nice way of helping you figure out what it's equal to. But I can see that if I compare each term to the one above, each of these terms is less than these terms. So I can say something about this. This will give me another finite number. I don't know what that number is, but it's less than 2. So I could say this is finite, or I could be even more specific and say this is less than 2. All right, one more. 1 plus 1/2 plus 1/3 plus 1/4, and so on. Just keep following that pattern. Each time the denominator just grows by 1. This one is pretty interesting. I'm actually going to write a few more terms here because I want to prove something to you, or at least convince you with an intuitive argument. You can take a guess at whether this gives us another finite number or not. If it's finite, you can take a stab at what it's actually equal to. You could also do that with this one. I'm going to give you an argument for why I think this is infinite. Even though this looks pretty similar to this one, this doesn't give us a finite number. And the reason is because I'm going to start grouping numbers together. So I'm going to start here. I've got 1/2 here. And then if I group the next 2 numbers together, and then the next 4, and then the next 8, and so on, and just keep doubling the length, then watch what happens. Here, 1/3 is bigger than 1/4. So when I add these together, it's bigger than 1/4 plus 1/4. And 1/4 plus 1/4 is 2/4 or 1/2. So this is bigger than 1/2. Now I'm going to go to the next 4. This is larger than 1/8 plus 1/8 plus 1/8 plus 1/8, which would be 4/8, which is 1/2. So this is bigger than 1/2. The next string it would be 8 long, and it would go all the way down to 1/16. And if you do 1/16 times 8, that's 8/16, that's 1/2. This will be bigger than 1/2. I can keep doing this forever. So I can keep grouping larger and larger groups together, and I can do that forever. So this thing is bigger than 1 plus 1/2 plus 1/2 plus 1/2, and just keep going. And if I add 1/2 forever, I definitely don't get anything finite. So we'll say that this diverges. Common shorthand for that is to just write the symbols equals infinity. Some people might get upset with you about that. I'm not worried about it right now. These are 3 great examples to keep in mind. Notice that with this one, the terms in the series are shrinking down to 0, but this whole series is adding up to something infinite. So a common mistake when you start looking at things like this is you really want to know whether these things are finite or infinite, because usually that's all you can say. That's really all you care about is showing whether it's going to be infinite or finite. This is a very special case. It's a very special type of series where you can say exactly what it's equal to, but usually you're just going to be interested in this. And a common mistake is to say, well, when I add these up, these terms are shrinking down to 0, so this is going to have to give me something finite. But this is a case where we've shown No, that doesn't always happen. It can go to infinity. It's worth taking some more time to look at series like this before you move on to just trying to figure out when series converge and when they diverge. Converge to something finite or not. This is called a geometric series. You may have seen that before. It's worth taking some time to look at geometric series before you move on to other things. So I'm going to make another short video looking at geometric series.